Hi everyone. So in this video we will cover all the fundamentals of data engineering, all the basics of data engineering, and we are going to use diagram based approach. Okay, and I promise you will not be bored at any point. Okay, it is just like a comic book, and I am sure you will enjoy this learning. Okay, so let's get started. So first is, what is data engineering? So we can just take an example of water supply system. So in this case, data is going to be your water and the destination will be the company or end user. So data engineering is nothing but how it is flowing from source to destination, or you can say how it is flowing from water supply system to your house. So in between there are many processes involved. So these are nothing but data pipeline. So that is the simple definition how data is getting from source to destination. Okay, so now next is data engineering life cycle. Okay, so let's for example take food engineering life cycle. So let's take an example of tomato. First is data generation, means growing the tomato in your farm. Okay, next is data ingestion, means bringing the tomato to your kitchen. First cut the tomato, then bring the tomato to your kitchen. Then next is data transformation, means you want to transform the tomato, so cook the tomato in your kitchen. Now next is storage. How will you store it? Okay, so store the tomato vegetable in pan or something so that you can eat it, so that you can serve it. So last is data serving. So finally we will serve the tomato to our customers. So that's how you can remember data engineering life cycle. Next is data generation. Okay, so how is data getting generated? So what are the types after that data is getting generated? So as you can see, there are three different types. So for easy understanding, we will consider them as three different types of boys. Okay, one is good boy, one is average boy, and one is bad boy. Okay, so we will look at this diagram to understand it better. So structured data is good boy. So as we all know, we can put the character of Captain America here. And second is unstructured. So we can use Hulk and Loki because sometimes they behave like a good boy, sometimes they behave like a bad boy. And third is unstructured, means completely bad. So we can use Thanos there. Okay, so you can remember these three characters, and these are nothing but the examples of these three data types. So for structured data type we use MySQL. This is just one example. Okay, there are many different types of databases for different types of data, but these are just one example. So for structured we can use MySQL. For unstructured, for semi-structured, we can use MongoDB. Like JSON, we will store data in JSON format. And unstructured means we can use Amazon S3. So In unstructured data we'll mostly store audio, video. Okay, so as you can see I have given examples from which this database is coming from. Okay, ERP systems is like structured, JSON file, XML file is semi structured, and this camera, microphone and scan documents, it can come under unstructured. Okay, now next is OLTP versus OLAP. So their full form is online transaction processing, second one is online analytical processing. Okay, so you can check the diagram. OLTP systems means you can remember it daily transactions, so we will use it daily. Okay, let's say you go to shop, you buy something, then we will do billing. Okay, each and every time we will do billing, so it is getting used daily. So for daily transactions remember this OLTP. Okay, and second one is we are not using it daily. Okay, let's say shop's head office. Okay, so general manager wants historical data. Let's say he wants profit loss report at the end of month, or sometimes even at the end of year. Okay, so end of month is not daily. So just remember like this. If you want to use daily transaction OLTP, if you want to use sometimes for checking historical data or profit loss report, then OLAP systems. Now SQL and NoSQL, it is very simple. Just remember SQL is table format, NoSQL is flexible format. Okay, so table you know row and columns, and in NoSQL we'll use JSON like document, key value pairs, graphs, etc. So look at this diagram. Banks want to store data in table format, then we will use SQL. Let's say Facebook wants to store the data in flexible format. Okay, because we can upload anything like audio, video, there is no structured. So in this case we'll use NoSQL. Okay, so just remember table format, flexible format. Now next we have row based and column based data. Okay, so as you can see the diagram, again we have two boys. So this red boy is saying I want to store name and the age of person 1, let's say Rocky, in single line, and then name and age of person 2 in second line. Okay, so in this case we will use row based storage. And this yellow boy is saying I don't want to store in single line, I have separate list of names, separate list of age. Okay, so in this case we will use column based storage. Again, do you remember OLTP? Okay, so like daily transaction, whenever we want to use daily transaction we can use row based storage. Like we had that example of billing 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 counter. Yes, I'll just show you. See, this OLTP means daily transaction, and the example was billing counter in the shop. And this OLAP is historical data. Let's say general manager of one company wants to see profit loss report at the end of month or at the end of year. So This is getting used sometimes and this is getting used daily. So in case of OLTP we will use row based, in case of OLAP we will use column based storage, and these are the example of database system. MySQL and Postgres is row based, and Redshift and BigQuery, these are the example of column based. These are example of OLAP systems, and these are examples of OLTP system. Now next is ETL versus ELT. So you can ignore this theoretical definition. I will just explain you with diagram. So just remember two scenarios. I want to cook right now, and second scenario is I will cook later. ETL means I want to cook right now. ELT means I will cook later. Okay. So first, if you want to cook right now, just you will buy the vegetables, okay, which is extract. You will wash the vegetable, you will cut it, then you will cook, which is transform, and then you will directly serve them on dining table and eat it, which is load. Okay, so this you are doing because you want to cook right now. But second scenario is you will cook later. So you will do extract, you buy the vegetables, but you don't cut it right now, you don't transform it right now, you will just store it first. Okay, so which is load. You will put it in fridge or refrigerator, and then I want to cook later means whenever you want to cook, then you can transform, you can wash, cut, and then cook them whenever you need. So this is ETL, this is ELT. Now full load versus incremental load. So in you can see the diagram. In full load you can remember Hulk. Okay, so he is always angry. Okay, so let's say whenever he has some new photos, he will completely throw the old album, and then he will reprint all the old photos with new photos. Okay, newly clicked photos. So he will delete old and then create it all over again with old photos, because he is always angry. On the other hand, Iron Man is sharp minded. Okay, he won't throw old album, he will use his head. Okay, so in incremental delta load, whenever Iron Man has some new photos, he will just add it in existing album. He is not going to throw the old album and then reprint all over again. He is not gonna do that. He will just add it in an existing album. So in full load you can remember Hulk, he is always angry. In incremental load you can remember Iron Man, he is sharp minded. Now next is upstream versus downstream systems. This is very simple, bro. Just remember waterfall. Okay, how waterfall flows from top to bottom, right? So from upstream to downstream. So what is upstream? Nothing, it just creates data. Just like in case of waterfall, water gets created upstream somewhere, right? What is downstream? Receive process and use the data. Okay, so it receives the water, process it, and then we can use it. like users can use the data. Okay, so upstream and downstream is same as waterfall. Upstream is create the data, downstream it is receive, process and use the data, or you can save water. Now next is data architecture, means end-to-end pipeline. So again let's take an example of water supply system. So in this analogy you assume data as water. So you will have to ask 4 questions. From where the water is coming from? So water is coming from source. It can be anything. Second question is how it will travel. So there are two processes involved, ingestion and transformation. So ingestion is like pulling the water from the source, and transformation means you can say, you can assume filtering the water. Okay. Now third is how water will be stored in the storage. It's very simple, it could be tank or anything. Then how people will use it. So finally we will serve that water. So obviously users will use that water from tap water. Okay, so these are the 4 questions that you have to remember. In the data analogy we can say like source will be anything like software, database. Okay, and second is how it will travel, how data is going to travel. Ingestion means we will just pull the data, okay, from the source like database. And second is transformation, means we will transform the data. Okay, we will clean it. Then third is how data will be stored. It will be stored in any data warehouse. We'll see it later in detail. And for this we will serve it. So generally we use data for analytics. We will create reports, we will create dashboards, or we will create ML, machine learning models. Now next is what are the two types of data processing. So these are batch processing and streaming processing. So what exactly is batch and streaming? Okay, so you can use this diagram. You can just remember these two characters. For batch processing you can remember Hulk. Okay, so Hulk is very lazy, he doesn't like to finish his works on time. Okay, so he says, you just create the list of works, I will finish it at the end of the day, all at once. Okay, so that is batch processing. Data is collected and then we can process it in chunks, all at once. Okay, for streaming processing you can remember the character of Captain America. So he is very obedient, he is a good boy, as I said earlier. So he likes to finish his work as soon as it gets assigned to him on that same very time. Okay, he says, I will finish the works as soon as any new work is created for him. He doesn't like to collect the work and then finish them later. He doesn't like that. So that is streaming processing. Data is processed the moment. Now next question is, what is fact table, dimension table, and what is meant by hierarchies? So for fact table you can remember Loki. So generally fact table stores measurement related information. Okay, so you can remember it like this. Loki says, how many cakes did I make? Okay, so he wants numerical information. which is measurement related information. So generally these types are stored in fact table. Now next is dimension table. So it stores descriptive information about fact table. Okay. So Loki says how many cakes did I make? So in dimension table, Thanos is saying which cakes, who bought the cake, what are the cake ingredients, on which date customer bought this cake. Okay. So these are the descriptive questions, descriptive information about fact table. So you can remember it like this. These two characters you can remember, Loki and Thanos. Yeah, one more is pending, hierarchies. So what is hierarchy? So it's just a level from top to bottom. So generally it is used only at the time of creating dashboards and reports. So suppose let's say we have date table, so there we can create hierarchy. At the top level there will be year, then below that there will be quarter, below that there will be month and day. After that we can also write hours, but till days it's sufficient. Okay. So these are the hierarchies. These are nothing but the levels from top to bottom. Now next question is star schema and snowflake schema. So in star schema, in the center there will be fact table, and around that multiple dimension tables will be there. For example, let's say sales table is the central fact table. Around that these are the connected tables: customer, dates, orders, product. So it is forming star like design, star like diagram. So that is why it is called star schema. Now what is snowflake schema? It is same as star schema actually. It's just that one additional concepts is there, like dimension table will have sub dimension tables. That is the only difference. So here customer is the dimension table, then it can have related subtables like customer address. Correct? This is sub dimension table. So let's say product is the dimension table. It can have sub dimension table like product category. Okay. So that is the only difference. Otherwise it is the same as star schema. It's just that additional sub dimension tables are connected, and this generally forms snowflakes like diagram. That is why it is called snowflake schema. Okay, so next question is dimensions, type 1, type 2 and type 3. So just remember three boys: good boy, bad boy and average boy. So type 1 is bad boy. He is very lazy. It only stores latest data. Okay, he is very lazy. He doesn't want anything old. Type 2 is good boy. So he stores all the versions of the table, old table plus new, old data plus new data. And type 3 is average boy. So he stores latest version of data plus one previous version. Because he is average, he does not store all the old data, just one previous version and latest. So that's how you can remember type 1, type 2 and type 3. These are nothing but dimensions. These terminologies are basically used in data engineering projects. So that's why you need to understand them. Now next is data warehouse layers. So basically there are three types of data warehouse layers, which are staging, core and marts. So let's understand one by one. So again take example of water supply system. So there are three different layers for that. So in staging layer, dirty water is collected. Okay. So in staging tank, we will store dirty water. There in core stage, we will perform cleansing process in that tank. Okay. We will basically perform all the procedures to clean that water. This is core. And final will be data mart. Okay. So only required amount of water will be stored there. Okay. So let's say tomorrow they have to send that water to all the city, so only required amount they will store, not everything. Okay, so that is data mart. So here water is data. Now next is data marts. Okay, so it is nothing but the mini version of data warehouse. So let's take an example of Dubai Mall. Okay, let's say Dubai Mall is data warehouse. So inside that Dubai Mall, we just want to buy the mobile. So we will go to Apple Store. So that Apple Store is data mart. Okay, as I have written here, subject specific warehouses. So data mart focuses on specific department. So if I need mobile, I will go to Apple Store. Okay, so data mart is nothing but mini version of data warehouse. Now next is data lake versus data warehouse versus lake house. Okay, so again let's take example of tanks, water tanks. So tank which stores raw rainwater, that will be data lake. Okay, so the tank which stores clean water, then will put it in the bottle and then we will label it and then it will be ready to drink. So that clean water we will store in data warehouse. And let's say there is one tank which stores both raw water and clean water. So it stores both in some separate department. So that will be lake house. Okay, so data lake is raw data, that means all kinds of data. Data warehouse is clean data which will be used for business reporting, and lake house is both raw plus clean data. Okay, it will be used for both storage and also for reporting. So next is medallion architecture. It contains three types of layers: bronze layer, silver layer and gold layer. So again let's take an example of water supply system. So bronze layer is the tank which stores raw rainwater. Okay, this is bronze layer. Then silver layer is the tank which stores clean water. Okay, clean, labeled and ready to drink water is stored in silver layer. And in gold layer only required amount of water is stored. So let's say that tank will supply some specific volume of water to limited cities. So only that much water will be stored in gold layer, which is required amount of water. So in data engineering analogy, bronze layer will store raw data, that means all kinds of data, silver layer will store clean and structured data, okay, and final layer will be gold layer, where we will store only required amount of data, which will be used for dashboard, reports and machine learning models. So next is delta lake versus data lake. Let's take an example of Iron Man's Jarvis system. So if you have watched that movie, you must remember that. So old Jarvis system says I store raw data in cheap storage like S3, Azure Blob and HDFS. So it's going to have couple of issues. First issue is if two people are writing data at the same time, data can get corrupted. And second issue is hard to track changes and rollback. Third data is it is very hard to update and delete. That means it is complicated. Okay, so these three issues are there in Iron Man's old Jarvis system. So new Jarvis system is nothing but it is solving all these three issues. Okay, new Jarvis system is solving all these three issues. So in this case, old Jarvis system is data lake, new Jarvis system is delta lake. Okay, so you can remember it like this. Now next question is big data basics. Means what really is big data, what is important in big data. So let's check the diagram. So as you can see, one missile system is attacking missiles on Dr. Doom. So if you have watched the Fantastic Four movie, then you would know Dr. Doom for sure. Okay, so let's say this missile system is hitting missiles on Dr. Doom, but he is not worried at all. He is just casually asking three questions. Okay, so which are these three questions? Bro, you are hitting missile, that's fine. Let's just tell me how much missiles are coming. Okay, how much missiles are coming means volume of missiles. Second question is how fast missiles are coming, that is velocity of missiles. Third question is what types of missiles are coming, means types means variety of missiles. Okay, so these three concepts are very much important in big data: volume, velocity and variety. These three questions you need to remember. Okay, but in this case we are not talking about missiles. Missiles means data. So next question is Apache Spark architecture. You don't need to look at any definition, formal definition. This funny diagram will explain you it in very easy to understand language. Okay, so the first let's take an example of restaurant. So in the restaurant there will be head chef. Okay, so in higher level he will plan what needs to be done and breaks it into smaller steps. Okay, then there will be kitchen assistants. Okay, so they will basically run these tasks in parallel on different machines. Okay, head chef will decide what needs to be done, kitchen assistants will run these tasks in parallel. Then we will plan the dish. Okay, preparation is done, now just we need to plan the dish. For whenever we cook something, we fry it in the last, right? So that's kind of same, and then finally we will eat it. Okay, that means we are making Spark actually do it. So head chef means Spark driver. Kitchen assistant means Spark executors. Planning the dish means transformation, and actually eating that dish means actions. Okay, so you need to remember it like this. So the next one is batch processing versus streaming processing. Okay, mm, let me close this navigation. Okay, so what is batch processing and what is streaming processing? So no need to learn any definition, just check out this diagram. Let's take an example of two boys. First one is Hulk, second one is Iron Man, Tony Stark. So the first one is very lazy. He doesn't like to work whole day. Okay, so what he will do? Hulk says, I will collect the data, store it, and then process it all at once. Okay, so he does not want to do things on time. So he will collect all the bugs and then he will process it in the night. That is batch processing. Now second one, streaming processing. So second one is Tony Stark, Iron Man. So he is very obedient, he is very active, he likes to finish his things on time. Okay, so he says he will process the data continuously as it arrives. Okay, so within the whole day, whenever the data is coming, he will process it on the very same time. Okay, so that is an example of streaming processing. And Apache Kafka is nothing but a tool which is used for streaming processing. We'll learn it in the deep later. As of now, just remember it like this. Apache Kafka is a tool for streaming processing. Now next question is Apache Hive. Okay, so before understanding Apache Hive, let's understand Hadoop. So what really is Hadoop? So as you can see in the diagram, it's nothing but a giant storage box which contains raw data files. Okay, it does not contain tables, just raw data files, which is very hard to query. So let's say, what if I want to query this raw data? If the data is in tables, so we can easily query it using SQL. We all know that, right? But what if it is raw data? So how can you query it? So for this, you need one magical tool called Apache Hive. So Apache Hive contains some superpowers. So what are those superpowers? So Apache Hive says, bro, you haven't really moved this raw data into database, okay? But still, I can look at these files as tables, okay? Because I have one superpower. Apache Hive says that, right? We haven't connected it to a database, still I can look at it as tables, okay? And let's say you want to query this raw data, I will figure out a way to process this data. Okay, we'll just going to use SQL like language, and Apache Hive will query it for us using its superpowers. Okay, in the background it can use anything like Apache Spark or let's say MapReduce. It's not our headache. Okay, we'll just use SQL like language, and Apache Hive will query it for us because Apache Hive can see this as tables. In fact, these are not actually tables, these are just raw data files. But Apache Hive can do it, so it's good. We can use it. And Apache Hive is generally prepared for batch processing and not real time processing. Okay, so remember that. Now, next question is Apache Airflow. So, Look at the diagram. Let's say I want to prepare a cake. Okay, I am hungry and now I want to prepare a cake. And in my mind, I know like steps as well, but not completely. I have couple of questions. Okay, so what are my questions? I have 5 questions. Okay, my first question is I know the steps to prepare a cake, but not the sequence. So, what is the sequence for preparing a cake? And answer is Apache Airflow. It will help me organizing tasks. Okay. My second question is I understand better with diagrams. Can I get a diagram for cake preparation steps? Answer is Apache Airflow. Apache Airflow will provide you flow charts. Now, my next question is at what time I should start making the cake? Okay, answer is Apache Airflow. It will act as a scheduler. It can help you schedule the tasks. My next question is now I have done enough talking. When do we actually start making the cake? Answer is Apache Airflow. It will run the actual tasks. Okay, it contains executor. My fifth question is I'm preparing a cake, but what if something goes wrong in that? Okay, how can I actually monitor it? Answer is Apache Airflow. It can help you monitoring the tasks. Okay, so these are the 5 questions which you can remember. And here I am not actually talking about the cake, I am talking about the task. Okay, now next is what is cloud computing. So I will explain you very easily with this diagram. So Doctor Strange, we all know Doctor Strange, right? If you have watched that movie. So but when he was young he was doing all the works, but now he says I am getting old, I can't do all the works. Now I don't want my own computers and server, I want to rent everything. Okay, because I don't want to manage them, so I don't want my own computers and servers, I want to rent. So that is nothing but cloud computing. You can rent computers and servers. And next one is infrastructure as a service, what is platform as a service, and what is software as a service. So again I have one diagram for that. So bro, our 3 boys are back again. So first one is good boy, infrastructure as a service. So he's a good boy, so he will do all the works, he will do everything. You don't worry about that. Okay, he will do everything. Everything means what? He will manage servers, he will manage operating systems. Okay, that includes everything. Our second boy is he's an average boy. Okay, platform as a service. So because he is average, so he will do average works, not too low, not too high. He will just build the apps. Okay, he won't do servers and operating system works. He will just build the apps. Third one is software as a service. He is the bad boy. He is the laziest one. Okay, so he will just use it. He will just use it ready-made app. He won't take care about servers. He won't take care about operating system. He is just going to use it because he is the laziest one. Bad boy. Okay. So these are our 3 boys. Infrastructure as a service, platform as a service and software as a service. Now next question is cloud data pipeline components, okay, which are storage, processing, orchestration and warehousing. Again we have a good diagram for that. So first, so let's take an example of water pipeline which is supplying drinking water to cities. Okay. So first is, so in the first tank they will collect raw water. Okay. In the first tank they will collect dirty raw water. Means what? We will store the raw data. Okay. First step is storing raw data. Now in the next process we will clean the water. Clean and transform the water. Same way we will transform and clean the data. Now third step is we'll make sure water flows through pipe in correct order and we will monitor the process. So we need to take care about order as well, bro. Okay. We need to take care about order and monitor. We will need to monitor the complete pipeline as well. Okay. So same way for data, we will schedule and monitor the jobs. Okay. So final step is in the final tank, cleaned water, completely filtered water is stored in the big tank for which is ready for drinking. Okay. Same way, cleaned and transformed data will be stored in data warehouse, which will be used for monitoring and creating dashboards and reports. Okay. Finally, cleaned, transformed, filtered data will be stored in data warehouse. We will use it for the dashboards and reports. Okay. It will be the final useful data. So this is our cloud data pipeline, which involves storage, processing, orchestration and warehousing. Now this last question is data serving layer. So let's read one comic book story. Okay, we all know Iron Man, Tony Stark. So Tony Stark has an exam tomorrow. Okay, he has not studied a whole year. He will only study one day. Okay. So he went to a library full of books, but he is not understanding a single book because data is very messy. He was not able to read. Now, what he will do? What is the solution? These are the solution. What is API? It's like a data generator machine. So we all use Instagram and Facebook, right? So whenever you create an account on Instagram, it will store the data in database. Okay. So you log in, you register, whatever you do, the data will be stored in database. Now what is BI tools? These are the tools which will be useful for showing in useful information. Okay, without doing any kind of coding. So these tools are Power BI, Tableau or anything else. For example, so on Instagram, let's say you want to check which account has the highest followers in India. Okay, we know that it is Virat Kohli, but still we want to show this information. So we can do this using BI tools. Now third one, dashboard. What is dashboard? So just now we have seen this useful information like highest followers account in India on Instagram. So same way, collection of useful information for business. So same way, many useful information, we can say metrics, we can we can check collection of metrics. Okay, this is dashboard. For example, highest followers in India, highest followers in USA, post with the highest likes. Okay, so collected, this is known as dashboard. Now using this API tools and dashboard, Iron Man will be very happy. Now he can easily read useful information there. Okay, and now he can study well and he will top the exam for sure.